Welcome to the NETL Regional Workforce Initiative webinar. Right now, you should see on your screen some basic information about how we are going to run this webinar today. All participants should be on mute for the duration of the webinar. If you're not on mute or you can hear yourself, please venture to mute yourself. Also, the slides for this presentation will be available on the NETL RWFI website. We have an archive site for all of our webinars, our past webinars. And if you'd like to know about future webinars, please feel free to reach out to us.
Thank you.
netl.rwfi@netl.doe.gov and subscribe to our email. So you see in front of you the webinar agenda for today. We're going to start off our webinar with introductions about the Regional Workforce Initiative and NETL from Anthony Armley, the NETL Regional Workforce Initiative Federal Coordinator. Then we'll jump right into the main topic of our webinar today, which is to discuss the USER report, U.S. Energy and Employment Report findings from 2020 from David Foster, the lead author of the report for the Energy Futures Initiative. And then, granted we have time, and I believe we should, we will have a short discussion about the regional and national impacts of the USER report, but also about some of the current conditions brought on by the recent events with COVID and economic slowdown. So with that being said, Anthony, I am ready when you are. Ready. And just let me know when to move the slides up.
Okay, thanks, Matt. Appreciate it. Really excited about this webinar for a couple of reasons. Number one, I think it's important that folks have an understanding about the U.S. Energy and Employment Report and the efforts they put into that. And in addition to that, I think it's really important right now to get information on what's going on, especially with the pandemic and how all this has been a factor. So what I like to do with these webinars is I'd give a quick introduction to everyone that's not familiar with the NETL Regional Workforce Initiative. So that's what I will do, and then I will give the floor to Dave Foster to talk about the report. So, Matt, slide. So the mission of the Regional Workforce Initiative is essentially an extension to the mission of our lab, which is to get technologies to market, but we focus on that from a regional strategic perspective. We use this platform to engage and collaborate with key stakeholders who we feel are critical for the deployment of our technologies that are related to energy and advanced manufacturing. Slide. So there's three things we strive to do. We strive under this initiative to collaborate, to coordinate, and to communicate with our key stakeholders. We do that in a number of ways, one of which is our monthly e-note. We put out an e-note every month that talks about high-level items related to NETL and the research that we do, funding opportunity announcements, training opportunities in the region, and any other miscellaneous items that we feel are relevant to the community. So if you don't get that monthly e-note, I ask that you send myself or Matt Garcia an email and ask us to subscribe, and we'd be glad to add you to our monthly e-note list. Slide. So the Regional Workforce Initiative came about in 2017 in a response to this current administration's priorities related to educating and training the workforce for the 21st century economy. Some of the key initiatives are to reskill Americans for the jobs of today and the future, which we feel strongly about are related to energy and advanced manufacturing. Another initiative was to improve the science, technology, and engineering and math workforce. So we do that in a number of ways. We communicate closely with the region related to workforce development and making sure that technologies come out of our lab at NETL, making sure that the community colleges and the technical schools understand what those skills are that could lead to jobs in our region related to the technologies that we develop. Next slide, Matt. Some of the key metrics to date, we've had a reach of over 400 individual and national stakeholders. Majority of these stakeholders are from Appalachia or the tri-state region, which consists of Southwest Pennsylvania, Southeast Ohio, and Northern West Virginia. These folks come from 150 different institutes and organizations representing workforce, economic development organizations, government, non-governmental organizations, and organizations focused on transforming energy and advanced manufacturing across Appalachia and even the country. So along with hosting these meetings on our NETL campuses, we also provide outreach in the form of, again, our monthly e-note newsletter. To date, we have almost 250 different folks that have registered or subscribed to our monthly e-note. And then we put together our periodic webinars on energy and advanced manufacturing, research, and workforce, in addition to economic development topics. To date, we've had over 700, nearly 800 now, registrants to our webinar series. These have been growing rapidly since we started doing these in the last year and a half, 2 years. Slide. So again, we focus on Appalachia because we feel there's a couple reasons why. It's historically a critical region for energy production and will continue to be so. It's strategically important area for related technologies in advanced manufacturing and even supercomputing. NETL has a supercomputer that is one of the top 50 related to supercomputing, and we're really proud of that and the opportunities that we can do with that supercomputer. We feel Appalachia is expected to enjoy a manufacturing renaissance, and we really already started to see that. I mean, you can look at the petrochemical industry for one. There's a huge plant going in Beaver County, just outside Pittsburgh, and right in the heart of Appalachia. And Appalachia has been an area that's been adversely affected by changes in the extraction of energy and the different manufacturing activities. Slide, please. So some of the key outcomes that we've had to date, I would say the consistent engagement with our key regional partners, the outreach that we've had, the networking, just having these webinars and introducing the different topics that NETL works on as part of our Energy 101 series has been huge. We've had a lot of people come back to us and tell us, hey, we didn't know NETL did work in sensors and controls or rare earth elements or advanced materials or the supercomputing. These are just some of the different examples. But by having these webinars related to some of these topics, it's a way to introduce the region to some of the great work that our researchers at our labs are doing, and really it promotes collaboration by doing that. The integration of a workforce work plan, I talked a little bit ago about taking the skills that would be needed from the technologies that are about 3 to 5 years from commercialization from our lab, and being able to provide that information to the local technical schools and community colleges so that if they're able to restructure some of their curriculum so that they can support some of these jobs that may come out of our lab, we can have these jobs right here in our own region. And that's a really big thing for us. And that's why we've integrated this workforce work plan. And then lastly, I would say the increased growth for potential of collaborative opportunities. Again, just the outreach and communicating some of the work that we do has been a huge outcome as part of this initiative. Slide, please. And then lastly, I just wanted to give those who aren't familiar just a quick overview of NETL. So NETL is one of the nation's only labs devoted to fossil energy research. We take great pride in the technologies that we have related to coal, oil, and gas. Our core competencies are basically computational science and engineering, materials, advanced materials, geologic and environmental systems, a lot of subsurface type activity, energy conversion engineering, and then we have a really strong systems engineering analysis group that really doesn't have any bias. They can look at the exact science, they can put a box around the area that you're interested in. So if you ever have any questions related to any of these core competencies, I think, feel free to reach out to us and we can get you in touch with the right researchers to discuss what issues you're having or any ideas that you may have to work together. So with that being said, I would like to give the opportunity for Dave Foster to give his US EER report. This is the third year now that NETL has had a webinar on the US EER report, and we've had great great feedback from folks that have dialed in, and so really excited to hear the latest information from Dave. And without further ado, thanks.
Great. Well, thank you very much, Anthony and Matt. It's great to be back with my former DOE colleagues once again and sharing information that we all played such a role in when we first started this project 5 years ago. And I especially also want to thank the Department of Energy for its support in the production of this report as well. Next slide. So just by way of a little background, this particular fifth US EER was released on March 23rd. It was produced in partnership between the National Association of State Energy Officials and the Energy Futures Initiative, which is the think tank that was put together by former Secretary Dr. Ernest Moniz in 2017. And we did it with the support of BW Research Partnership, who has consistently been the data gatherer of this project since it was started. You already know about me and my background, so let's go to the next slide. So for those of you who aren't completely familiar with this report, it is based on an annual supplemental employer survey that's conducted every year between September and November. And then it's integrated back into the Bureau of Labor Statistics Quarterly Census on Employment and Wages, or QCEW. We very specifically look at 5 sectors of the economy: fuels, electric power generation, transmission, distribution, and storage. Then we look at energy efficiency and separately look at motor vehicles. So we refer to the fuels, EPG, and TDS as making up the traditional energy sector. Energy efficiency is something that the Bureau of Labor Statistics has no specific information on at all, so we developed the definition of that. And motor vehicles we're interested in because the transportation sector is one of the largest consumers of energy, so understanding that relationship is important. Next slide. So the survey looks at 53 different energy efficiency, and motor vehicle technologies. For those of you who are into the Bureau of Labor Statistics, we actually do this across 186 of the North American Industrial Classification System codes. That's about 15% of them. And we do look at a lot more than just employment numbers. So we really dig into employer hiring expectations over the next 12 months. We look at the difficulties in hiring by both technology and by industrial job classification. We try to identify the high demand jobs and skills gaps so that we can do something about it, something that your initiative is very interested in. We also do a demographic study of the energy and motor vehicles energy efficiency workforce, and do this at a very granular level as well. Next slide. So I'm going to highlight just a few new things that we put into the 2020 user. I'm not going to go into all of these in any depth, so I encourage you to download the entire report off the usenergyjobs.org website and look at a number of these things. We dug into more real-world experience this time with specific interviews with interesting companies, organizations in the energy and manufacturing field. We did a strong partnership with the Energy Star program at EPA to try to have a better understanding of the Energy Star program impact on a range of different kinds of jobs. We also interviewed utilities to try to have a better sense as to how many people worked on energy efficiency programs, but for utilities. And finally, what I will spend some time on today is that we added a new section that was to establish what the 5-year trends in energy efficiency, and motor vehicles were. Next slide. So first, let's take a few key takeaways from just what happened in 2019. First of all, the traditional energy and reminding you that's fuels, electric power generation, transmission, distribution, and storage. Those three sections, along with energy efficiency, added 120,000 new jobs in 2019, outperforming the economy for the fifth year in a row, which added jobs at 1.2%, while those four sectors added jobs by 1.8%, 50% higher. Energy efficiency, again, led the way with 54,000 new jobs in 2019. Over the last 4 years, that's almost 330,000 new jobs, quite a remarkable growth. Fuels production added 26,000 new jobs. 18,000 of them were in oil and natural gas, while coal mining held steady. Solar jobs broke a 2-year trend, bouncing back and added 5,700 jobs after the 2-year decline, while a number of other areas, low emissions, natural gas, wind, CHP, geothermal, in electric power generation, all continued to grow. Next slide. Coal generation, on the other hand, dropped significantly by almost 8,000 jobs in 2019, even though, as I mentioned, coal mining itself increased slightly. And we have a little section in the report describing some of the factors that went into that. Motor vehicles added 20,000 jobs, which was really quite remarkable, continuing the growth that has gone on over the last 7-8 years in motor vehicles. However, the alternative fuel vehicle sector declined slightly. Overall, we saw hiring difficulty in 2019. Very ironic, continuing where we are, just continued to rise to over 84% overall among all 5 of those sectors, an increase of 7 percentage points year over year. And finally, as we headed into 2020, all these employers were predicting on average about 3% growth. So that was where we were headed before the remarkable events of the last 4.5 months, 5 months took place. Next slide. This just gives you an overview of what's gone on over the last 4 years. You can see that there was pretty steady job growth in most areas, slight decline 1 year in electric power generation, but you can see the numbers of people that work in the energy efficiency, and motor vehicle sector are a very important part of our economy, and that's really the theme of what I predominantly want to talk about today. Next slide. First, a quick little look at what's happening in the tri-state region where the NETL facilities really operate. First, a look at Pennsylvania over the last 3 years. Although there was a slight drop in 2019 in fuels production, down roughly 1,000 jobs in Pennsylvania, the other sectors, generation, transmission, energy efficiency, and motor vehicles, all grew significantly. And as my memory serves me right, Pennsylvania was one of the states that grew definitely within the top 10 on energy efficiency jobs. Next slide. Ohio, somewhat different mix of jobs than Pennsylvania. Obviously, motor vehicles is an extremely important part of the Ohio economy. Experienced a little bit of growth there too. Likewise, Ohio's energy efficiency added, I think, about 1,500 jobs. You saw transmission distribution holding roughly steady. Generation, Ohio was one of the states that experienced the largest amount of electric power generation job loss in the country. And in spite of that, you can see that the job loss was not was offset to some extent by increases in some of the other generation sources. Next slide. West Virginia, of course, on kind of the opposite trend from Ohio, where fuels production is still extremely important for the West Virginia economy. you can see that there was some very slight decrease, basically just held even year over year. I would point out that the large increase that you see in 2019 in transmission, distribution, and storage really was spread out over 2017, 2018, and 2019. But some of the issues relating to federal government data suppression prevented us from being able to put exactly what level of those transmission, predominantly oil gas transmission lines, happened exactly where. And we were able to fix that problem in 2019. But just so that you understand that it wasn't a one-year blurb there, that it actually went up to quite some degree in 2017, then took an even bigger jump in 2018 to where we're at today. So as Anthony mentioned, there's a very significant renaissance going on in the West Virginia, Pennsylvania, Appalachia area involving the petrochemical industry and the infrastructure that supports that. Next slide. I always think it's interesting, since energy efficiency is such a significant piece of how we think about energy consumption in these days, to look at the makeup of the energy efficiency industry. So we do this by both technology and by industrial sectors. So on the left-hand side, you can see in the 3 states how construction, for instance, makes up the largest sector of energy efficiency, but it's not uniform at all. And so you find that the kinds of jobs that exist in different states vary quite a bit. So you can see that Ohio has more manufacturing than the other states in energy efficiency, and there are other kind of variations that exist. The same kind of variations do happen in technologies, so that you will find in different states, different technologies tend to get concentrated on more. And so it's always interesting in understanding your own state or region, what the specialties are and what the opportunities for growth are. Next slide. And then another way of looking at this is within the state, as a percentage of the jobs, what are the variations in energy efficiency? And so here, even though West Virginia, of course, is a much smaller state in terms of size of the workforce and population, you can see its reliance on construction in energy efficiency work is greater than in either Ohio or Pennsylvania. And then when you look at technologies, you can again see that there's that variation. And interestingly, that West Virginia, a much higher concentration in advanced materials than it does in the HVAC systems, which actually tend to be the largest sector by technology in most states. So interesting variations, and when you start thinking about economic development or workforce development programs, it's interesting to know where your strengths and specialties are as places to potentially grow off of, and where your opportunities for new growth are as well. Next slide. So now I want to get into talking a little bit about the 5-year trends that we explore in the 2020 U.S. Energy and Employment Report, and then relate that back to some of what's going on with us today in the very that we're facing. So certainly the theme of our 5-year review of jobs is that the energy jobs of tomorrow are going to be very different than the energy jobs we have today, and that transformation is already underway. We did an extensive interview with Mike Mulvaney, the Director of Energy and Infrastructure for the United Association of Plumbers, Fitters, Welders, and he incidentally told me that they have 3,000 members on any given day working on the Shell cracker plant in Southwest Pennsylvania. As he liked to say, it used to be when he got out of high school that on Friday you somebody would join their apprenticeship program on the following Monday. But today, the entire world has changed quite a bit. As he said, high school counselors today are encouraging kids to go to college instead of acknowledging that our work can still provide a very good living. So it's interesting to me today that most of their apprentices now join the program in their late 20s, not in their late teens. And a very high percentage of them have had at least a year or two of some form of post high school education. Then they come back to doing the work that has become far more complex and far more different, but still very remunerative to them. And as he said, alongside the traditional energy work that they have always done, they are now seeing big increases in energy efficiency technologies. And as he put it, we're just in the first or second inning of smart buildings. So that's the world of work in energy and how it's rapidly changing. So let's look at the next slide and what some of these 5-year trends were in each of these sectors. Perhaps the most important thing that I think we noted is that today there are 3.3 million Americans who work producing and distributing the fuels and electricity that power our lives. But at the same time, there are almost 5 million Americans in energy efficiency and the motor vehicle sector who are working every day to use that energy more efficiently. And so you have these two things going on simultaneously that some people would instinctively think undermine each other, because the more efficiently you use something, theoretically, the less you're going to need. But that is not the dynamic we're facing in America today. Next slide. And the reason that's the case is that we've been on a trajectory now for quite a number of years in which energy production and decoupling and consumption have decoupled. And most people would wonder, is that good for jobs? Well, the fact is that it has been very good for jobs in the United States. And that's something that we want to stress is very important to remember when we think about recovery from the current downturn that we're experiencing. That the energy sector has had this kind of secret sauce to it, where the energy intensity has decreased year over year for a couple of decades now. And at the same time, we've been able to produce more and more energy more and more cheaply. And that energy production and distribution being done more and more efficiently and cheaply has produced 250,000 new jobs in the last 5 years, while at the same time, our efforts to use energy more efficiently in our buildings, our cars, our various other forms of transportation, that likewise has created an enormous number of new jobs, in this case, 481,000. So that's a theme that we really point to as why we've been so successful in outgrowing the rest of the economy in terms of job production. Next slide. So I want to take a quick look at what's happened over the last 5 years in each of these different sectors that the user looks at. So here we have fuels production. So oil and gas fuels, when you look at just those two fossil fuels alone that have been impacted by the shale gas revolution of the last 15 years or so, they now employ almost 900,000 people and have added 73,000 jobs since 2015 when we started doing this survey. During that same period of time, coal lost about 17,000 jobs, which was a decline of roughly 18%. But if you look over in the slide on the left, you'll see that of that decline, almost all of it happened at the front end of the last 5 years. And the coal jobs have been relatively stable till the end of this year. In terms of some of the alternative fuels like ethanol and biofuels, they actually declined over the 5-year period. And corn ethanol went down by about 12,000 jobs, but the other biofuels were up by 65%. So some real shift, even though the actual number of jobs didn't change all that much in the various biofuels. There were some real shifts in terms of the specifics. One thing that I always want to stress when you're talking about change in technologies is that they can have very uneven geographic effects. So it's important to understand that of the mining and extraction jobs that make up 55% of all fossil fuel jobs, 88, almost 90% of those are located in just 10 states. So as we think about economic impacts, it's very important to think about the geography of where those impacts take place because they're not always uniform. Next slide. In electric power generation, two important things happened in the last 5 years that then had employment impacts. First of all, in the slide on the left, you can see how natural gas displaced coal as the largest net power generator in the United States, and you can see that march upward of the green columns. Meanwhile, over in the renewable sphere, you see another march upward by another green column, and that's wind, displacing hydropower as the largest source of renewable generation. So let's see what kind of impact that had. Next slide. So during the last 4 years, we see that the overall electric power generation, and I'm only looking at 4-year cycle here, not 5, added 52,000 jobs, with most of those in natural gas, wind, and combined heat and power. As I mentioned, coal generation lost 8,000 jobs last year, a total of 18,000 over the last 4. And now employs just under 80,000 people, while natural gas, quite a bit larger at almost 122,000. As I mentioned, wind is the largest renewable source in net generation, and it's second to solar in employment at almost 115,000 jobs. And what we've seen in solar, which had a very meteoric rise up until I'm thinking it's 2016, then declined for 2 years, rose a little bit this year, has been a big shift in the amount of megawatts that are installed into the utility sector, which has far fewer employees to produce far more megawatts than does residential solar. Next slide. In transmission, distribution, and storage, or what some of us might think of as energy infrastructure, over that 5-year period added 156,000 new jobs, came across a variety of different technologies, certainly driven in part, as it was in West Virginia, by expanding oil and gas production, but also by much greater renewables deployment, that wind and utility scale solar. But then grid modernization, smart grid, and storage demand all played a role as well in that TDS increase. For instance, battery storage alone added over 18,000 jobs during that period of time. Next slide. And then energy efficiency. When you go back to look at energy efficiency over the entire 5-year period, added over 400,000 jobs, the most of any of the sectors we looked at. The traditional HVAC employers, from a technology point of view, added the most new jobs, almost 80,000. Efficient lighting was number 2, adding 52,000 new jobs as more and more lighting was retrofitted into buildings. And in 2019, I mentioned that we did a special examination of the Energy Star program, and we determined that over 826,000 jobs are associated with those Energy Star standards. So really a very important contributor to setting the goals for how both construction, manufacturing, and professional services are all delivered to provide meeting those efficiency standards. Next slide. And then on energy efficiency, it is interesting to see those occupational industries and how they are distributed over the years. Construction continues to be the largest of those at about 54%. However, as I mentioned, we determined that hiring difficulty, almost without exception throughout this entire 5-year period, was the most difficult in energy efficiency construction. And so even while the technology growth was expanding inside construction, in some years you actually saw the out-and-out employment drop, as you did in from 2016 down to 2017 in this slide. So that even though more actual energy efficiency work was done, it was done by fewer people. So that has been something that we have always wanted to stress, that when we think about opportunities for workforce development and growth, even in the middle of the problems we're facing today, over the long term, energy efficiency construction skills are in high demand. The other thing to stress in terms of how energy jobs are changing has been the growth in professional services in energy efficiency. So if you ever needed something to underscore more sharply how data management has become an important part of the design of how we accomplish energy efficiency, looking at the fact that professional services added over 113,000 jobs in energy efficiency, more than any one of these others, that's an important factor to remember. Next slide. And finally, taking a look at the motor vehicles and component parts industries. Motor vehicles added 134,000 new jobs over that 5-year period. Remarkably, 95,000 of those were in manufacturing. So we really have had a manufacturing rebirth in the transportation sector over the last decade in America. Alternative fuel vehicles now employ 266,000 Americans. They added over 76,000 jobs since 2015. Of those alternative fuel vehicles, the largest growth sector, was in all-electric vehicles, which added 36,000 jobs. And at the end of 2019, almost 500,000 component parts employees, their jobs were contributing to meeting fuel efficiency standards. So that's another example of how the drive toward efficiency actually helped stimulate economic growth, and did that in the motor vehicles industry just as it did in the energy efficiency sector of the rest of the energy. Next slide. And just to drive this point home again, this shows the difference in job growth by the overall economy over the last 5 years, shown by those blue bars, and then energy overall, which are in the orange bar, energy efficiency in specific in the gray bar, and then the transmission, distribution, storage section in the yellow bar. And those 3 sectors consistently outperformed the rest of the economy. And it's something that we do well to remember when we start crafting both federal and state stimulus recovery plans. Next slide. Now I want to shift gears a little bit and look at the energy sector overall and what it looks like in comparison to what's going on in our economy today. So in this slide, we're leaving motor vehicles out of this. They are not energy jobs. As I mentioned, we're interested in them because of all the energy consumption. But this slide looks at the energy and energy efficiency sectors, sets aside the 1 million people or so who work in gas stations, and then breaks them up by both technology area, i.e. fuels, generation, transmission, efficiency, and then looks at their occupational sectors, construction, professional services, breaks them all down, and then looks at the sum total. So you see that 37% of all those jobs are in construction, 17% in professional services, 13% in manufacturing. The very core of this sector is the utility sector, but it only makes up about 11% of the employment. Roughly the same in wholesale trade, 9% in mining and extraction, 1% in agriculture and forestry, 2% in other services. So that's what we're talking about when we look at the core of the energy workforce. Next slide. Now, what happened in the last Great Recession? And we thought this comparison was important because it gives us a certain sense of where we're at right now from a, quote, typical recession versus a COVID-driven recession. So what happened during 2007-2010? Well, number one, manufacturing declined overall by 18%. But it was much worse in some of the key manufacturing states, where 16 states lost over 20% of all their manufacturing. Professional services, on the other hand, declined by only 2% during that period of time. Construction was the hardest hit and dropped by over 33%. Meanwhile, and remember that construction is the largest sector within energy. Wholesale trade declined by about 10%. Mining had a very interesting experience back in the recession because if some of you remember, that was the time in which horizontal drilling, hydraulic fracturing was really taking off. And so you actually saw very uneven effects in the last recession where mining dropped by 15 to 45% in 33 states. But then in Pennsylvania, Alaska, and North Dakota, employment increased by 8, 12, and 67%. So the overall declines in mining were actually fairly small during the last recession. And finally, and I think this is very important, that utilities, although not a large share of energy employment, was extraordinarily stable and lost almost no jobs with almost no fluctuation. And agriculture had seasonal impacts, but almost no overall impacts on the energy, on its overall employment. Next slide. So this gives you sort of a more detailed look at what happened in construction overall, and then some of the specialty sectors of construction in which energy efficiency employment in particular is concentrated. And so you can see those kind of sharp declines that went on. Next slide. So how does this relate to what we're seeing right now? Currently our unemployment data is incomplete. It's not particularly up to date. It lags. In this case, the most recent high-level data that we have dates back truly to the middle of April when most of the interviews were done. But what we do know is that the COVID-19 recession, job decline, depression, however you want to characterize it, is highly concentrated in sectors that were not impacted in exactly the same way as we saw in the 2007-2010 era. So number one, we've seen that leisure and hospitality employment lost 46% or over 8 million jobs in March and April alone. Then there was extremely large declines in retail, travel, and to some extent, healthcare. So what happens when you look at the current reporting on the job loss that we've seen in the energy sector, and what does that look like compared to what happened during the last recession? So look at construction, which makes up 37% of energy and energy efficiency employment. We've lost in March and April, the estimates of job declines were 33,000 and almost 1 million. But that makes up 14% of the construction workforce versus 33% of the job loss that we saw during the height of the Great Recession. When you look at professional services, you see a little bit of the reverse, but this again is a reflection of what's happened in leisure, hospitality, and retail. So the job loss in professional services at about 10% is quite a bit bigger than it was during the recession when it was at 2%. Manufacturing, you see something somewhat similar to construction. Makes up 13% of energy employment. To date, we've lost about 11% of manufacturing versus the 18% during the Great Recession. Utilities, you can see it's almost identical to what we saw, that utilities lost a total of about 3,000 jobs out of over 600 some thousand, basically a 0.5% of job loss versus no job loss during the Great Recession. And so you can see going down through here, the comparison between what's happening in the energy sector then. What does this lead us to look at? Well, in a typical recession, there will be a high risk assessment for that construction work to continue going down, as there would be for manufacturing. But we don't expect to see a lot of job loss in the utility sector. And these are of importance, I think, when we start structuring both what we need to do to respond to avoid further job loss in those sectors at high risk, and what we need to do to have a solid recovery plan that's built around the job production capacity of the energy and energy efficiency sectors. Next slide. So this is what, at the Energy Futures Initiative, we've been talking a lot about the need to have an energy jobs coalition that brings all Americans together around a vision of understanding how important the energy sector is to revitalizing everything else. So we need to look at those energy sectors where we have lost employment, and we need to have a strategy that puts them all back to work, not just some that work in some technologies. We need to have them all back to work, because it's this mix of technologies, this mix of job skills that's been really driving job growth, producing lots more energy more cheaply and then using it in an ever more efficient manner. That's what makes the rest of the American economy hum. Because everybody needs energy, whether you're in healthcare, retail, hospitality, travel. Energy is what makes our economy run. And so when we're doing it in this fashion, producing more of it more cheaply and then using it more efficiently, we provide exactly what, if you're a hospital, if you're a building, if you're a bank, if you're an office, we make everybody work in a more efficient, effective, and prosperous manner. So we're advocating really that we need to invest particularly in these high job growth sectors like energy efficiency and energy infrastructure, where we saw this very important job growth and job growth that outgrew the rest of the economy. And that's the kind of investments that we can make at a regional level, we can make them at a state level, at a city level. We can empower the federal government, for instance, to use some of its borrowing and spending authority to target growth in these sectors that we know have a proven track record. We also need to do something that I know is near and dear to NETL's heart, which is to look at technologies like carbon capture sequestration, or look at small modular reactors, look at the new energy technologies, because those historically have been what have helped us produce more energy more cheaply. And so looking at this as an opportunity moment to push the development of new energy technologies, another important economic development tool. When I worked at the Department of Energy and served on DOE's Loan Program Office Board, I thought it was one of the most remarkable opportunity structures that we had in America. And so taking advantage of expanding on the track record of the Loan Program Office, for having helped deploy those new energy technologies. This is an opportunity to really look at that. And then again, those energy tax credits that historically have helped get new technologies off the ground and new manufacturing technologies in particular, like 48C, revitalizing all those tax credits, extending them, using them as the proven economic development tools that they've been. And then finally, and I think your initiative is just right on the mark, that you can have all the great technologies in the world, but if you don't have the people who know how to do them, know how to install them, know how to operate them, and know how to make a livelihood off of them, then unfortunately, we run into a roadblock as we have with energy efficiency in the construction sector, where lack of skills has held back growth. So Matt and Anthony, that's my presentation, and turn it back to you, Matt, for any questions.
Great, thank you, Dave. That was extremely informative. A lot of great information there. I'm going to ask also that Anthony can join us now. We have a couple of minutes. And one of the things that I wanted to ask, this is a really easy question. Given the 5-year time span that you saw these trends in, and given the current situation, recently today, it was announced that 2.4 million more people were added to the unemployment numbers, bringing it to almost 39 million unemployed. What role, given those 5-year trends, where's the biggest opportunity for energy to help in the recovery process?
I think there are two big opportunities right now. One is in energy efficiency, and that's because it's a proven job creator, and it does it in a variety of different kinds of industrial occupations. So that's why I think noting that 37% of those jobs are in construction, another, forgetting what the number was, 18% are in professional services. So you have a really wide range of occupational opportunities, putting people to work on retrofitting and making buildings and industrial settings more energy efficient. You have an opportunity to touch every single state, every single county in the country with an energy efficiency jobs program. Let's say at EFI, we did a survey and determined that there are 840,000 public buildings in the United States. Think if we had a program that started out by doing an energy audit on every one of those buildings, put in place an energy efficiency program on putting more efficient HVAC systems, insulation, lighting, so forth in all of those buildings, we would be able to have a very significant opportunity to put those construction workers right back on the job. Some 13–14% of them who've been laid off before it gets any worse. And then obviously professional services, when so much of energy efficiency now depends on the management of technology, the design and management, as it does on the installation. So another great opportunity to put people with a completely different set of skills back to work. Then in addition, I think the infrastructure is the other big opportunity. We have an infrastructure problem in this country that goes far beyond energy infrastructure, and I think everybody on this webinar knows it. If you've driven down an urban street recently, if you've tried to use the internet in a rural part of the country, you know we have big infrastructure problems that go far beyond energy, but energy would be key to helping make a lot of the rest of our infrastructure work better. So investing in those two sectors, I think, have very large job opportunities. They create demand for manufacturing products and for an awful lot of the rest of the services that people have been thrown out of work for. So when you're thinking about what happened to the restaurant industry or for other services that people supply, then you need to get people back to work so that they can purchase the services that they're no longer using. So that's how I look at it, Matt.
Okay, great. So one of the great things about the report is that it covers this very hard to define sector called energy efficiency. Could you give us some words on how you guys have defined it, and with the juxtaposition between energy efficiency and construction, given the suggestions you just made?
Yeah. Well, when we first started grappling with this problem, we realized that it wasn't just a definition problem, it was also going to be a communication problem, in the sense that when we gathered data about whether an employer was using their employees to do energy efficiency work, we needed to have a way of talking about energy efficiency that was easily understood by thousands of people. And so we gravitated toward the Energy Star program and made that the heart of how we defined energy efficiency jobs. And so if you know about the Energy Star program, the Energy Star program is based on, I believe it's the top 15% essentially of performance in a given technology. And so it's a constantly moving target, which is what makes this so interesting. That if you want to be an Energy Star technology, you have to be at the top of the heap, not just reach a threshold that you get across and then 95% of the people are doing the same thing you're doing. So that was kind of the core of how we looked at it. Then we did expand it a little bit beyond that, because there are things like insulation that don't quite fit into that box. There are some forms of lighting, like fluorescent lighting, that we chose to keep in, which I don't believe is included in Energy Star programs anymore. But we wanted to have technologies and processes that contributed to energy efficiency and had a high standard to get in. So in terms of the communication problem, it turned out to be a very good choice, because Energy Star is a globally recognized standard that everybody gets, that, hey, I'm either Energy Star certified or I'm not. And so it was very interesting to see how the employers responded to that. When we then went over to the motor vehicles industry, we used the CAFE standards. And that again turned out to be an effective communication tool, because all the automotive parts manufacturers that we interviewed had a very good idea as to whether or not the products they were producing were contributing to the final manufacturers reaching those CAFE standards, because that was the nature of the dialogue that they had with the original equipment manufacturers. So that was how we arrived at it. If you want to look at the very precise wording of the definition, I would encourage you to go to the usenergyjobs.org website, download not only the report, but the appendices, and you'll see very, very precise definitions. And you can actually see the questionnaire that was administered to the employers, so you can see exactly how they were asked. And we had a very specific list of technology products that we asked them if they used and or manufactured.
Okay, well, thank you. Thanks a lot, Dave. Thanks a lot, Anthony. I think we're at the top of the hour, so I think we'll end it there. Thanks once again, everybody online, for joining us today. Just to recap, the slides will be up shortly at our NETL.RWFI website and our webinar archive. And we will endeavor to get a recording of this up as soon as we can, probably on our NETL YouTube site, but may just also be on the website, the RWFI website as well. Thanks again, everybody. Hope you have a great afternoon, and see you next time.